Look at this video. Okay, now look at this video. Seems familiar? Well, this is my semi-successful attempt at getting the Lisa-Jones curves, or as some might like to call it, a Lisa-Jones figure. The setup I used was some clay in the form of a teardrop-like shape hanging down from some string tied to a long stick held up with two cardboard boxes. Now, you may have seen similar attempts from viral videos on the internet attempting to recreate this phenomenon with sand or paint free-flowing from a bottle or container of sorts, and their contraptions are far better than mine and produce better results than mine as well. But we're not here to look into the extent of how successful certain setups are. We're here to answer why. Why does it swing that way to create those patterns that we call Lisa-Jones curves? Well, to understand this, first we have to know some basic physics. So I'm going to skip right ahead into the important parts, and if you want to know more, you can Google for this, but essentially, we're going to be talking about wave motion. Now, looking at the wave right here, we have the amplitude, which is the maximum displacement of particles from the rest position. So the bigger the amplitude, the more energy the waves carry. Next, we have wavelength, which is the shortest distance between any 2 points in a wave that is in phase. When it comes to understanding wave motion, you also need to understand frequency and period. Frequency is the number of complete waves produced per second, and period is the time to make one complete oscillation or wave. Now that we've skimmed through the basics, we move on to what a Lisa-Jones figure essentially is. To put it simply, it's a pattern produced when the intersection of two sine waves, which with its axis are perpendicular together. So this GIF right here essentially describes how the patterns are formed. And notice that when both sine waves are the same frequency, it produces a circle. It is also capable of producing an ellipse or a parabola depending on the numbers input into the equations of the curve, but the mathematics here is pretty complex, so we shall not dive in. So, now that we've covered the basics of both, can you see how the Lisa-Jones pendulums, or the patterns, might be used to study wave motion and their properties in physics? This video is simply meant to explain a bit about the Lisa-Jones curves, and this topic covers quite a bit of advanced math, so we will not be going through them today, but if you are curious, do read up. That is it for today's video. I hope everyone learned something. Stay safe and stay curious. Bye!